Alright, hello guys. Welcome into this fabulous Friday. I know you missed, you don't only see my face in these videos, but I know you missed seeing me yesterday. Um, you all did decently well on the test yesterday. I know there were some mistakes on my part. I just want to ask you to please be patient with me. I know some of you reached out to me, and I will make sure, I take into account the questions that I made some little typos or mistakes on. You guys just gotta be patient with me. This is new for both of us. I apologize for some of the mistakes though. You guys, your grades will all be fine, I promise. I will post those this weekend. I'm gonna look over some of the ones where there was a little bit of typos. I know for sure there was one that it was just completely wrong, and I got that. And I will make sure that gets fixed. I'll make sure that will not happen again on your next test and quiz. So we will be using that system for the rest of the time we're online, for however long that is. Just a couple things again. You have 5 minutes. That 5 minutes is for that question. So you make sure you are sure about that question before you move on. You cannot go back. I know that stinks. This platform, it doesn't allow you to go back, but it will allow you to spend as much that 5 minutes on that question as you can. If there's any concerns or feedback you want to give me, please let me know. But I really am going to use that system. I think it's the best system to keep everyone as honest and as possible. And so that is the system we're going to be going with 4 quizzes and tests, unless something special arises that I need to use another system of assessment. Alright, so I'll have those grades posted as soon as possible. I know they were graded, but I'm going to, I'm going to add some points for some of the questions that were a little messed up, okay? So I just want you guys to know I'm aware of that. Alright, and so for attendance, all you have to do is fill out the Google form that is attached there. I'm going to tell you about some special in the video a little later to make sure that you're watching. And then also just any questions. I like to just put the questions out there. That'll be a way for me to get questions in. You don't have an assignment for this today. You'll have the assignment actually on Monday. That'll be you don't have to watch a video, you should do an assignment, like your homework. Alright, so to keep this video, let's trim it down. So we're doing the Pythagorean Theorem today. We've actually talked about the Pythagorean Theorem before. Not the first time we're seeing this. They actually use it throughout a lot of our sections, and they just start teaching it now when they teach it. We're going to go into a bunch about right triangles. So that's what the section is called. Is Pythagorean Theorem and its converse. So remember, I've always talked about this is the hypotenuse, and we have 2 legs of a triangle. Legs, hypotenuse. The Pythagorean Theorem is it's about right triangles. You can only use this for right triangles. So right triangle or right angles here is going to be a squared plus b squared. So the squares of the 2 legs added together equals the hypotenuse squared. That is the Pythagorean Theorem, no matter what. I think we're already familiar with this, so I don't feel like I need to spend a ton of time explaining it, but that is the Pythagorean Theorem. So we're going to do problems with this and others. So let me go to the next page, alright? Alright, so the first basic questions are just asking you to use the Pythagorean Theorem to find the third side. Let me actually move this down so you guys can see this. Alright, so they want you to just find the missing side using the Pythagorean Theorem. So they give you a right triangle, and they want you to find the missing side, okay? So alright, so in little letter A, you have the 2 legs. So that they can be A or B, it doesn't matter which one is which, as long as the legs are A and B and the hypotenuse is always C. So they just did 6 squared plus 15 squared equals x squared. Then they square rooted 261. You don't need to simplify the radical. You just write it as a decimal. So whatever 3 root 29, or in a round to the nearest tenth. But they just simplified the radical. But I just need you to do square root of 261 to some sort of decimal. And we'll go through that in a second. And so here, for part B, you have the hypotenuse and one of the legs. So they made x where one of the A or B is, depending, does not matter, plus the other leg squared equals 11 squared. They subtracted 9 squared from 11 squared and got 40. And they square rooted 40, and you would get some kind of decimal, but they did 2 root 10. But if you did the square root of 40 in your calculator, you would get some sort of decimal. Alright, so quickly pause, and then when you come back, we will try 1A and 1B. So try 1A and 1B on your own, and then come back, and we'll do those. Alright. So, if you came back now, alright, 1A and 1B, let's do those relatively quickly. Alright, so 1A, we have the 2 legs. We are missing the hypotenuse, so we would do 17 squared plus 7 squared. So that would be 289 is 17 squared plus 49 is 7 squared equals x squared or c squared, okay? So when you add them together, it's 338. And then when you square root both sides, you get x is approximately, again, rounded to the nearest tenth, I got 18.4. Alright? So that would be 1a. 1b, 25 is the hypotenuse, 22 and x are the legs. So I just did 22 squared plus x squared, doesn't matter if you have x squared plus 22 squared, equals 25 squared. So that would be 484 plus x squared equals 625. Alright, then you subtract 484, so you get x squared equals 141. Get ahead of myself. You square root both sides, and you get x equals approximately, it's approximate 11.9 because you're rounding that. So if you're ever approximating, you just put those little squiggly equals instead of like an actual equal sign, because approximate is not exactly that. That's the square root of 141, by the way, 141. So those are 1a and 1b. Alright, nothing too crazy. Alright, so now we're going to move right into the next part. They're called Pythagorean triples. Alright, so this gets a little bit tricky, I have to be honest with you. Alright, so Pythagorean triples. I will probably provide you with these on some sort of assessment, but let's talk about them. So a Pythagorean triple is basically like a set of, these are like Pythagorean Theorem, like they work every single time. So there's like a set of them that like, all the right triangles, they're going to have like, so there's 4 types of Pythagorean triples they show you here. These are the 4 we're going to talk about. Sorry guys, I'm just looking for my eraser. Alright, I'm just going to erase this in my head. Alright, so we have 4 Pythagorean triples, and you're going to have to know these, but again, I think I might allow you guys to use these during an assessment. We can get there when we get there. But let's just talk about what they are and what do they mean, like what the heck are Pythagorean triples. So, like it says, a set of non-3-0 numbers where a squared plus b squared equals c squared, like they work. So if I so for example, right, you have 3, 4, 5 triangles. So if I do 9 plus 16, I get 25. So 3, 4, 5 triangles, this works. That's like a Pythagorean triple. It works. A squared plus b squared equals c squared. And if you do, okay, like 5, 12, 13, so you have, 5, so what's that, 25 plus 144 is 169, and that's the square root of 169 is 13. So they work with the Pythagorean theorem. Now what happens here is now you're going to be given, let's say your sides are 10 and 24. You have to figure out that the same number times 5 would be 10, and the same number times 12 would be 24, and then you should know that the other side would be 13 times that number, the hypotenuse or whatever. Or 8, so 8 times 2 is 16, 15 times 2 is 30, 17 times 2 is 34. So what you're going to do is you're going to be given 2 of the sides. You're going to have to decide what Pythagorean triple is going on with that triangle, alright? I know it sounds a little bit weird. Let's just go into a problem and then maybe, of course, like you're not here to have questions, but this is why I'm doing that Google form with questions, and I'll try to answer those best I can. Alright, I gotta move this down a little bit. Alright, so it says use the Pythagorean triple to find x. So we can use the Pythagorean theorem, but on a quiz or test, I'll probably have you identify the Pythagorean triple. Like that's probably what I'll do to make sure you guys understand this concept, okay? So in this first problem, right, so they give you 15, 12, and x. So you got to think about 15 and 12, the factors of 15 and 12. Well, you know that 15 and 12 are both multiples of 3. So you know that 3 times 5 is 15, and 3 times 4 is 12, right? So because 3, 4, and 5 is the Pythagorean triple, the missing length is 3 times 3, which is 9. If you check it, 12 squared plus 9 squared equals 15 squared. What they did was they saw that the same number, so like 3 multiplied by 4 and 5 gave me the 2 of the sides, right? 3 times 5 is 15, 3 times 4 is 12. So the third, that means it's going to be a 3, 4, 5 triangle since one's with 5, one's with 4. The last one's going to be 3 times 3, which is 9. So it's the same number multiplied by 3, 4, and 5. Or remember, like the other ones that were on the other page, like 8, 15, 17, or 5, 12, and 13. It's those. So they're all be multiples of that number. All right, and then if you can check it by using the Pythagorean Theorem. But they want you to identify what triple are we looking at. All right, let me do 2A with you guys. I know this is a little bit harder of a concept, but then I'll let you guys pause, try 2B, and then come back and we'll go over it. All right, so 2A. All right, so we look. So let me think about some numbers. Well, I know that 4. This is what I went through things. I know that, think about a number that goes into both the numbers here, okay? So in this case, 4 goes into 48 and 20, okay? That's a number that does go into both of them. Look for a number that goes into both these numbers. That would be my first kind of like trick, okay? Look for a number that goes into both of them. In this case, well, 48, and if you divide 48, so if you do 48 divided by 4, I end up getting 12. Alright, so 12 is part of one of my Pythagorean triples. Alright, well let's look at if I do 20 divided by 4, I get 5, right? So find a number that goes into both of them, divide it, right? Well, if I look at my Pythagorean triples there, I see that I have a 5, 12, 13 Pythagorean triple. Where 5 and 12, the biggest side's always going to be my hypotenuse. So where 5 and 12 would be my 2 legs, and 13 would be my hypotenuse. So what happens is, since this side is 4 times 12, and this side is 5 times 4, and it's those two parts of a Pythagorean triple multiplied by the same number, x is going to equal, so it would be a 5, 12, 13 triangle, x is going to equal 13 times that same number, 4, so that would be 52. So what you do is you identify the Pythagorean triple, so 5, 12, 13, or whatever, 3, 4, 5. You figure out, okay, so I have the 5 side, or I have the 5 side, I have the 12 side, I need the 13 side, so I multiply 13 times the number that the 12 and the 5 are multiplied by. So you have to identify the Pythagorean triple, and then the one part of the Pythagorean triple you don't have, whatever number that is, you multiply it by the same number that the other two numbers of the Pythagorean triple are multiplied by. This is very hard to do without you guys in person. So I would pause and I would try 2B, okay? Alright, so now you came back. 2B. Alright, well hopefully you saw, okay, 2. 2 is the number that is the factor that goes into 14 and 50. Alright, well if I do 50 divided by 2, I get 25. If I do 14 divided by 2, I get 7. If I look back at my Pythagorean triples, okay, I see that there's a 7, 24, 25 triangle where 25 is the hypotenuse, which is, this is the hypotenuse, and 24 and 7 are the legs. So the only part of this I'm missing is 24, and everything's multiplied by 2. Alright, so all I'm going to do is, so x would equal the other part of that Pythagorean triple I'm missing, 24, alright, times 2, which would be 48. So x is going to equal 48. That would be my third side there. So you identify what Pythagorean triple you're looking at. The one number of the Pythagorean triple you don't have, and multiply it by the same number the other two pieces of the Pythagorean triple were multiplied by. Again, I would start off with identifying a number that goes into both the numbers there, and kind of see, okay, are these numbers part of a Pythagorean triple? Normally when they ask you for these directions, there's not going to be one that's not part of a Pythagorean triple, at least I know of. Alright? I would not give you one like that. That would just be that would trick you guys. I don't want to trick you guys. And I promise on the test I wasn't trying to trick you guys. Alright, and as I'm going to the next example, I want you guys to know that I'm wearing Donald Duck Christmas socks. I've been seeing a lot of Christmas going on for this coronavirus thing. And so I am wearing Donald Duck Christmas socks. That's going to be the answer to the question on the Google form, to make sure you guys are actually watching these videos, okay? Alright, so we still have one more example we want to go over. Hopefully I'm not going over, I don't think I'm going to be going over my, trying to keep these videos to a shorter length. Alright, so moving into the last part of this example. So basically, alright, so last piece. Alright, so back in the day when we were first learning about triangles, I'm going to talk while I'm moving this. We had to figure out whether we could have a triangle based on three sides, right? So remember we had to figure out, okay, like if I add these two sides together, it's greater than the third side. Remember, you had to do three inequalities and figure out if the third side was always greater. If the two added together were always greater than the third side. Well, that's going to be one part of the problem we have to do next. So basically, what's going to happen is we're going to get three sides that could be three sides of a triangle. First off, we have to decide if those three sides could form a triangle by doing those three inequalities. Now I'm going to go through an example in a second. If they do form a triangle, then we're going to use the Pythagorean Theorem to figure out what type of triangle it is. So if you add the two smaller sides squared and they equal the biggest side squared, so if you can form a triangle with the three sides. If you have 3, 4, and 5, and 3 squared plus 4 squared equals 5 squared, then it is the triangle that you have with those three sides is a right triangle. But we have two other cases, all right? I'm going to talk from down here. I'll just lift this up. If the square of the bigger side is less than the two other sides, the two smaller sides squared added together, then you have an acute triangle. If the bigger side squared is greater than the two other smaller sides added together, then you have an obtuse triangle. So you have three options. You have to figure out if it's a triangle. Then you have to figure out is it acute, obtuse, or right. So you kind of have two steps really to this problem. All right. So let me go to the first example. I think it'll make a lot more sense. Okay. So determine whether these three can be a triangle, and then determine what type of triangle they can be. Okay, so they give you the numbers 7, 14, and 16. So first you have to check, you have three inequalities to check if the two sides added together is greater than the third side. So first check, is 7 plus 14 greater than 16? Yes, it is. Is 14 plus 16 greater than 7? Yes, it is. Is 7 plus 16 greater than 14? Yes, it is. So you have to do three inequalities, check to make sure the two sides are greater than the third side every single time. We learned this earlier in the year. If this is true, then these three can form a triangle. Once we do that, then we're going to plug them into the Pythagorean Theorem and see what type of triangle it is. So in this case, 16 squared is greater than 7 squared plus 14 squared. So if you go back and look at your rules, if the biggest side, 16 squared, so always the biggest side is always going to be C. So if the biggest side squared is bigger than the two smaller sides squared added together, then that means this triangle is obtuse based on the theorems in the last page. Okay, right now I just want to end. I want you guys to pause, try 4a, and that'll be all you have to do. So pause, try 4a, I'm going to go over it. So pause and then try it, and then you will see me go over it when you're done. Alright, so you're back now. Okay, I think there's actually another example there that I did not go through. I think you guys can go through that yourself. But let's look at 4a, okay? Alright, so 4a, they give you 11, 60, and 61. So first we're going to check to make sure this can be a triangle, right? So if I do this, right, I can do 11 plus 60. Is that greater than 61? If I did that, yes it is. It's going to be 71, right? Also, 61 plus 11, so if you guys did this check, is greater than 60. And then I would do 60 plus 61, is that greater than 11? Yes it is. What happens is basically all three inequalities check out. So these three sides can form a triangle. So now what I'm going to do is I'm going to check. I'm going to see, okay, I'm going to do, is 61 squared greater than, less than, or equal to 60 squared plus 11 squared? So it's always going to be the two smaller sides squared plus the biggest side. So this is going to be 3721 is going to be equal to 3600 plus 121. Well, that's actually going to equal each other. So since these two values equal each other, okay, we're going to have a right, not just a triangle, but a right triangle. Since a squared plus b squared equals c squared. Alright? Now, I actually want to show you guys 4C because I think that's kind of important. They actually show that in example, the second part of example 2. If you look at 4C, right? So let's start with, so I have 6.2, 13.8, and 20, right? So let's try adding. Let's start doing like my 3 inequalities, right? This is why this is important to these inequalities. Why I want to show you 4C. So if I do 6.2 plus 13.8, is that greater than 20? When you do that, actually, you get 20. And 20 is not greater than 20. So what happens here, if you do this, these 3 inequalities, and one of them doesn't work out, you can already start off by saying, you know, these three sides will not form a triangle. If I can write. I'll get out of the way in a second, guys. Will not form a triangle. So again, what's going to happen is sorry, you can't really see that, but if one of these inequalities does not work out, you can't form a triangle with those 3 sides, and then your problem's just done there. That's why it's important you have to check this first. I know some guys don't like doing a lot of work. You got to check that first. Then, if it does work out, then check to see what kind of triangle it is. So that's section 8.2. So answer your Google form. That's your attendance. And ask me any questions. I know that the Pythagorean triple thing might be confusing. You also actually have an assignment. Your homework assignment on this will be on Monday. That'll be all you have to do is just that assignment. That'll be your attendance on Monday. But for today, just answer the Google form. Have a great weekend. Hope you've enjoyed these lessons so far. Hope you're not too upset about your test. I promise it'll be fine. And I will see you guys, you'll see me again on Tuesday for the next lesson.